So today we are talking about vector equations of a line. Okay, so there are such things as equations for these different vectors. So you're going to learn how to write them and to solve problems respectively. So this right here, what you see, vector R equals vector A plus T vector B. That's the equation. That's the basic set of equation for a vector, where R is the general position vector. So that's like, it's kind of like what Y equals is for a normal line. Vector R equals is like what Y is. A is your given position vector of a point. Vector B is the direction vector parallel to the line. And T is a parameter. Okay, so T is like your variable. So T can change. It can be T, S, alpha, beta, gamma. It could be any particular letter. But that is the basic setup for a vector equation. Okay, so that's pretty much the bulk of the notes. Okay, we're gonna be doing examples. We're gonna be doing examples until the end of the period. No, why would you want to write these down? Okay, so here we go. We're gonna be just doing examples. Okay, we'll start off with something that's simple and work our way to the more advanced. Okay, so I'll give you a minute to write this down before I get started. All right, so we're gonna find the vector equation of the line that goes through the point 1, -1, 3, and parallel to that particular vector. Now do realize that when you are writing an equation, you do need to write it in the form of R, vector R equals vector A, plus some parameter, vector B. Okay, now B represents your direction vector. So when you look at this information that's given to you in part A, that 1, -1, and 3, that actually represents the point, that represents your position. Okay?
Not the direction.
Not the direction. But right here when it says, and parallel to the vector of this, that vector tells you your direction. So in this one problem, they give you everything you need to write your equation. This point right here represents A, your position, and then this represents vector B. Okay? It's just separated. Alright? So when you write your equation, and you can write it any one of 3 ways. You can write it in column format. You can write it in unit vector format with the i's, j's, and k's. Anyway, okay? So, simple enough as this. Since my direction vector is already in i's, j's, and k's, let's write it as such, okay? So how would I write 1, -1, and 3 in that format? How would I do that?
I, negative, y, minus j, minus, plus k, plus 3k.
Plus 3k, very good. So there's A, plus your parameter, and then this is already in that format. And there's your answer to A. There's your vector. Well, remember, parallel lines have the same slope. So that means it has the same direction, so you wouldn't have to adjust that direction vector at all.
So, the parameter, what does that affect? Are we putting anything later?
Yeah, there'll be things later. So in this case, the parameter is kind of like what x is. Like when we look at like a standard equation, like y equals 3x plus 2. You know, it can actually represent like a
the equation is y equals mx plus b pretty much.
Right. Yeah. All right. Now B says find the vector equation of the line through these 2 respective points. Okay. So you have to find the vector equation that goes through those points. Then what do you think we are definitely going to need here to write an equation?
Direction vector.
We need a direction vector. That's true. And we need what? What other piece?
Position.
And the position vector. Now, one of these points can represent your position vector. Okay? Either one. It really doesn't matter because both of these, can be, starting point going from A to B, or you go from B to A. Okay, so any one of these could be your position vector. But how do we find our direction vector? You do subtract things. Exactly. In order to find a vector equation, you need the vector. Right here, you just have the endpoints. So you actually need to figure out, okay, what is vector AB? And to do so, you're going to do what we did in the problem of the day and subtract B from A. So when we do that, we're going to do -2 minus 1, which is -3. 1 minus 0,
One,
1, and 1 minus a negative 4.
5.
Wait, where are you going?
Because you're doing 1 minus negative 4. It's b minus a. So there is your direction vector. So this is your b, and any one of these points can be your a. Really doesn't matter which one you want to make it. Cool. So our equation can be written in the same format, or you can write it in column format. Which way do you want to do it?
Column.
Cool. So then you'll do your position vector, 0, 1, negative 4, plus your parameter, and then your direction vector, negative 3, 1, and 5.
And that's it.
And that's it.
How did you choose that AB was B?
Because remember, the b in the equation represents your direction vector. So we need to have the vector itself to figure that out. So all these were endpoints. So you actually need to subtract and find the vector. That represents your direction vector. Question? Now C says we're going to find the acute angle between the two lines. We have to find the angle between two vectors, so that means we're going to use what formula?
The angle two vector formula.
Which involves what? What's your
Cosine theta equals dot product of VW over magnitude V times magnitude W.
We are going to use this formula right here. This is the formula to find the angle between two vectors. Now the question is, which I think was the question before, what's vector V and what's vector W?
Doesn't matter.
Yes, it does.
Why?
Because we're trying to find the angle between this line here, I'm going to label this R2, and this line here, which I'm going to label R1. Okay? Now, what part of these equations are going to go in for vector V, and which part of this equation is going to go in for vector W? Is it going to be the position, or is it going to be the direction? Which one do you think?
Direction is just angle. Doesn't matter about where it's at.
Exactly. It doesn't matter where it starts, but it matters where it's going to create that angle. So whenever you have to find the angle between two lines and you have the equation, you're going to be taking the direction vector. So we need this vector right here. I'm going to use a different color. So we're going to use this vector right here. And I'm going to use this vector here. I'm going to use two direction vectors for the two lines. Okay? And just to make it a little bit easier, this is a -1, a +3, and a -1. So we need to do the dot product between these two vectors. Give myself a little bit more space. Dot product. That's going to be -3 times -1. 3. 1 times 3. 5 times -1. And now we have to do the magnitude of both vectors. Can you guys do the magnitude of both vectors, please? What's the magnitude of R1
Square root.
and of R2?
Square root.
Okay. We can't use our calculator here for this one because these are definitely not something that we can do using our unit circle. So this is going to be a +1 over the square root of 11 times the square root of 35.
Which is square root of 385, which is equal to 19 point something. You
So-
take the inverse of that, and
Uh-huh.
you get 87.1.
Make sure you're very careful that the calculator knows it's doing 1 divided by the product of square root of 11 and square root of 35. Make sure you're also in degree mode. Alright, here's the next example. Alright, so the points A and B have the respective coordinates, and L1 has the equation that's given to you. We need to do two show problems. We need to show that point A lies on L, and we need to show that AB is perpendicular to L. Okay? So, to show that a point actually lies on the line is basically you need to take the point and set it equal to this equation and then solve for t. And the thing is that you're going to end up with 3 different equations, okay? But no matter what that T should be the same number for each one of the three equations. That is how you show if a point lies on a particular line. Okay? So I'll say that again while I'm writing it out. So you have your point A. Okay? You set it equal to your equation. So that's -1, -1, 2. And so basically you're going to split it. You're going to do your first line, your second line, and your third line to create three different equations. That's -2 equals -1 plus 1t. That's -3 equals -1 plus 2t. And -4 equals 2 plus 6t. And basically you're going to solve for t in all three equations. And the thing is that t should be the same for all three equations. That's one way you can do it. Another way you could do it is you could solve for one of the equations and then plug that value into the other two equations to see if they're true. So substitution, yeah. So either or works. So if I use this first equation and I solve it, what does t equal? -1. So at this point, I can solve all the other three and see if it equals -1. Or I can plug in -1 into t to see if -3 doesn't equal -3 and if -4 doesn't equal -4. Either way. Okay? That does equal -3. And does 2 plus 6 times -1 equal -4?
Yeah, check it out.
Okay? That's how you show that A. So in this case, since these are true statements, then yes, it does lie on L1. If it said determine if point A lies on L1, this is what you would do, and then you would say yes, it does lie on L1.
So we have to say that yes, it does, or can we just show that t equals -1t?
Yeah, on this problem, since it's a show, you just show that and you're done. But if it ever said determine if A is on the line, then you know you would say yes. Now it says show that vector AB is perpendicular to L1. Well, do we have vector AB yet? No, we just have the point, so we actually have to find vector AB. How do we find vector AB?
Subtract
B minus A. So if I do B minus A, what's -6 minus the -2? What is a -7 minus the -3? What is a -2 minus the -4? So we have this vector. Now how do you determine if two vectors are parallel to each other? Huh? The dot product has to equal 0. So when we do the dot product with L,
Wait, are we doing perpendicular though?
that's how you show that two things are perpendicular. You do the dot product. Now the question is, with line L, which part are you using? The second one again, you're using the direction. Because that's going to tell you whether or not it's going to hit that other vector AB at a 90-degree angle. So you're going to use 1, 2, and 6. -1 times, -4 times 1?
-4, -8.
Whoa.
I'm loving it.
-4, -8, and what's 2 times 6?
Check with my calculator.
-4 and -8 make a -12. -12 plus 12 is indeed 0.
Yeah, I got it. 0.
Talking the dot product equals the magnitudes.
Or that way too. Yes. So again, the dot product equals 0, then you know that they're perpendicular. If you want to figure out their parallel, you can see if they're scalar multiples of each other, or the dot product equals their magnitudes, the product of their magnitudes.